Hello and welcome. My name is Dana Brown. I work for Xojo. In this lesson, we are going to focus on the statements provided by the Xojo language so we can use them when we need to repeat the same fragment of code. In fact, it is very common that in our apps we need to repeat the same task or block of code multiple times. In these cases, we can use the loop structure statements found in the Xojo language. In fact, Xojo offers several of these, so we are going to look at which ones we should use and when, depending on the kind of logic we need to handle. Let's suppose that we need to add a pop-up menu to our project that displays a number of options, which are a series of common options that will be always available. To do this, we can find the pop-up menu control under the Library panel. So we only need to drag and drop it into our window layout as we did in previous videos. The pop-up menu control offers a series of event handlers that let us include the code to execute as a response to a given action from the user. For example, one of these event handlers is the open event, so we can instruct it to execute a fragment of code every time the control is initialized. So let's add the open event handler and let's put in practice the first of these repetition structures. Let's say that we want our pop-up menu to offer a total of 10 options for the user to choose from, and that can be done using the inspector panel. So let's add these via code in order to see how these repetition structures work. The first one I want to show you is the one starting with the for keyword. Next to that keyword, we need to put a variable name that will be used as the index or counter for the number of times that needs to be executed by the code inside the block. We already know what variables are and how they work from previous lessons. As we do when declaring a variable, we need to assign a data type to it because it will be handling numbers. The variables we use for a for loop need to be an integer or double data type. Next, we need to give this variable the range of values that will be assigned to it. That is the number of times it's going to repeat the code inside the for block. The number of times is what from the initial value to the final value given, and by default it will be increasing the initial value by 1 until the final value is reached. So in our example, let's say that the initial value is 1 and the final value is 10. Observe the use of the word to keyword in the range definition. So in this case, the n variable will be assigned the values 1, 2, 3 sequentially on the loop iteration. In order to close the for loop structure, we simply need to use the next keyword. Every statement written inside this for next block will be the one executed the amount of times set by the values in the x to z range through the counter. And the one important thing to remember, every variable declared inside that block would be visible only to the code inside it and not by the outer code. That means that if we declare a new x variable as an integer inside this block, we wouldn't be able to access that variable before we enter the for block, and neither when normal code execution resumes after the next keyword. Returning back to our example, we want to add a total of 10 options. So we start using the me keyword, being the one we have to use every time we need to reference the control containing the code to execute. And in that case, it would be pop-up menu 1. In fact, we could substitute the me keyword with the pop-up menu 1 name of the control, but because we are including the code inside the control itself, it's always better to practice using me. In previous lessons, we looked at the available documentation for the pop-up menu. One of the available methods for this control is add row. This one method allows us to add new items to the menu. So let's type me, add row, and then the expected string as a parameter as we saw in the documentation. So we can use a literal string or the concatenation of a literal text with the content of a string variable, something we already know how to do from previous lessons, but in this case, we're going to use a literal string concatenated with the value of the n variable previously converted to a string using the toString function. So as you can see, this for next loop will be executing this statement a total of 10 times, and we'll add 10 options to the pop-up menu, option 1, option 2, option 3, etc. If we run our example app at this point, we can see how all these options have been added to the control, so we can choose from them. But there are still more options we can use in our for next loops, providing more flexibility about how to iterate the count range. For example, instead of iterating the range values incrementally, or as it is in this case, we can also do it in the opposite direction. So we can go from 10 to 1. We need to change the to keyword with the down to keyword. That is, instead of incrementing the counter value from the starting range value to the end range value, it will do it in the opposite direction, decreasing by 1 from the starting range value to the ending range value. If we run our example app at this point, you will see how the pop-up menu entries will reflect this change in the number value from 10 down to 1. But let's say now that we want to add just some values. For example, increasing the counter value by 2. For that, we need to add the step keyword with the value that will be added to the counter on each loop iteration. If we use a value of 2, then the values assigned to the n variable would be 1, 3, 5, 7, and 9 until it reaches the ending value of the range. You get the idea. So as the next one would be 11, and this one is over the maximum range value, it wouldn't be assigned and the loop would end at that point. As we can see here, but when it is about working with loops, there are a couple of very useful additional keywords that we need to know. The first one is the continue keyword. What does it do? Well, let's suppose that we're interested in adding just odd number entries to our pop-up menu. So we can use a conditional expression. So if the values of the n value is odd, something that we know by dividing it by 2, so if the rest of the division is 0, that would mean that the number is even. Then continue, instruction would be executed, and that means that the loop will jump to the next counter value without executing the remaining code found after the continue keyword. If we run our example app again now, we can verify that the for next loop only added the odd number value entries, while if we simply modify the conditional expression so it checks against odd numbers, then it will add the entries matching even numbers. The second keyword I was talking about is the exit keyword. In this case, when the exit instruction is found and executed, then it will be ending the loop execution even if it hasn't reached the maximum counter value, and the code execution flow will continue with the first line found after the next keyword. So in order to test this one, let's say that if the n value is greater than 5, then the loop only will add a total of 5 entries, and it will end the loop execution, resuming the code execution with the message box statement. And as you can see now, that is precisely what it did as expected, adding a total of 5 rows and displaying then the message dialog telling that we are outside the loop. In order, you can see in more detail how this works. Let's type 4 as the maximum and 2 as the value to compare with, so there are less iterations in the loop. And let's set a breakpoint in the first line of code. So when the app is run and the breakpoint is reached, we jump into the debugger panel to see how this works step by step. Here we can see that the n variable has been initialized with the 0 value. And during the first loop iteration, n gets a value of 1. That is the value from the initial range value. So in the next line, the n value is compared to see if this is greater than 2. And because it's evaluated as false, then the condition is not met, executing thus the line of code, adding the entry to the pop-up menu. In the next loop iteration, n gets a value of 2. The condition is still evaluated as false, so it needs so it adds a new entry to the pop-up menu, and the loop iterates again, setting 3 as the new value to n. But in this case, the condition is met, so the exit instruction executes. And as you see, this means that the loop will end and the execution is resumed with the first line of code after the next keyword that closes the for next loop structure. Of course, it's also possible to combine several for next loops. So we can add a new one that will iterate from 4 down to 1. Let's change the variable name. Remember, we can reuse variable names inside the same scope. And let's see what happens when we run the app. We jump into the debugger panel, and we start in the outer loop, and then we reach the inner for next loop. It will iterate, adding some new items to the pop-up menu as many times as instructed in the counter range. And once it finishes, we can see how the code execution jumps again to the outer loop, so the n gets a new value, and it executes again for the inner for next loop. One thing you need to be aware of is that this kind of loop will interrupt the responsiveness of the user interactions on the UI, so it is something to consider in those cases when you need to iterate over a big range of values. Of course, Xojo provides more advanced features in the framework to avoid that happening. If we click on the Resume button in the debugger panel, we can see how all of the items have been added to the pop-up menu, taking the order expressed by both the outer and the inner for next loops. When we work with combined loops, we can use the exit keyword, as we saw, in order to continue with the next step in the iteration of the outer loop. So let's see this through an example. The technique is the same. We will still use the exit keyword. For example, let's use a conditional comparison here. If we run our example at this point, we can see how the I variable gets the range values on every iteration from the for next loop. And once it reaches the 3 value, the condition is met, and it exits the inner loop, resuming the execution in the outer loop. So a new value is assigned to the n variable, and it will enter the inner loop again. But it may be the case, and probably you'll want to do this more than once, where you're going to want to exit not just from the inner loop, but also from the outer one. The syntax you need to use for this would be exit for, and then the name of the counter variable associated with the for next loop you want to exit from. So here it would be the n variable name. If we run our app after this change, you can see how this time the execution will be resumed in the message box line once the condition is met, and thus the exit for n statement is executed. Here it doesn't continue with the outer for next loop iteration, but jumps directly to the message box line of code. But for next is not the only loop structure option you can use in Xojo. In the next for next structure, we can see how the number of iterations is handled through a variable, taking the values of the expressed range, but many times the only thing we need is to repeat a block of code always when a condition is always met. For situations like this, we can use the while Wend loop. And in this case, we need to write the conditional expression after the while keyword. For example, while the n is less than 11, the condition is met, then it will execute the block of code inside the loop body. In this case, we can declare the n variable as an integer data type, and we will assign to it initial value of 1. Then, inside the loop body, we will be adding new items to the pop-up menu while the condition is met. But as you can see, here you need to take the control of the variable or expression that will be evaluated. Otherwise, you may find that it will always be evaluated as true, and thus the loop will never end, something known as an infinite loop, executing again and again the code inside the loop body. So in order to avoid that scenario, let's increase the end value just inside the loop body. If we run the app at this point, we can see how we get the same result as we used for the for next loop. Of course, with this loop construction, we can also use the continue and exit keywords as we did using the for next construction, and they will behave the same way. The third loop structure we're going to see is the one using do, loop, until. In this case, the conditional expression is to be evaluated at the end of the block, so we can type loop until n is greater than 10. As with the previous while Wend case, we declare our variable in the main body of the event handler, and we assign the initial value of 1 to it, and then we write the code we want to execute inside the loop, me.addRow n.toString, and let's increase the variable value by 1 so we don't get stuck into an endless loop. So what's the main difference between using do loop or while Wend? As you can see here, the use of this loop construction assures us that the code inside the loop body will be executed at least one time, while using the while Wend structure, that's not the case because it does the conditional checking at the beginning. And if it is met, then the code or main body wouldn't be executed. If we run the app at this point, we can see once again that we achieve the same results. Of course, you can use here the continue and exit keywords, offering the same behavior already seen. In addition, do loop is more flexible than while Wend because we can decide if we want to check the conditional expression at the end of the block or at the beginning. So here it would be more similar to the behavior found in the while Wend. Even when we use the do loop construction, we can check for two conditional expressions, one at the beginning of the loop and the second one at the end. So in this example, the conditional check will be made both at the beginning of the loop construction and at the end of it. So the loop will end when any of these expressions is evaluated as true. In this case, the condition that's going to be met first is the one put at the end of the construction because the I variable is going to be greater than 5 before n is greater than 10. And that is what we can see when we run our app again. So how can we put this into practice? Let's create a simple app where we will be able to automate the creation of multiplication tables ranging from 0 to 10. Let's write a for next loop in the Open Event Handler for the default Window 1 window of this desktop app. Such loop will add a total of 10 entries to the pop-up menu. Next, let's add a list box control to our user interface. And with the list box selected in the Layout Editor, let's access the Inspector panel to change the column count property, so it will be displaying a total of 3 columns. Then let's add a new event handler to the pop-up menu, Change. This will be the one in charge of executing the associated code every time the user changes the selected item in the pop-up. With the change event selected for the pop-up menu, we will write the code in charge of displaying the multiplication table for the selected entry in the pop-up menu, using for that a new for next loop ranging from 0 to 10. Result equals to n by the selected number in the pop-up menu. To get that number, we're going to be using one of the other pop-up menu properties. So if we access the Help for Pop-up Menu 1, we can see how among all the available properties, there's one named Selected Row Index, being the one giving us the index of the selected item or row in the menu. So let's access this property value from our code to get the value of the selected number. And after declaring a new index integer variable, we'll assign to it the value of the pop-up menu 1.selected row index. So we only need to multiply the value got by the n on every iteration by the value of the index variable. Then we instruct the listbox1 control to add a new row with the values we're interested in for every column. If we check the documentation for the listbox control, we can see that it offers the addRow function or method where we have to pass along the series of values to be added on every column. So here it's as simple as listbox1.addRow and then pass along the index value for the first column. So here we're going to add index.toString, then the n value for the second listbox column, also converted to a string, and finally the result value for the third listbox column, also previously converted to a string. But before we run this example app, let's instruct the list box to delete all the existing rows so it works right, adding a new series of rows every time the change event is fired. This is done calling the method removeAllRows on the list box, using for that the already known dot notation. Once again, the use of this and other methods is something we can find by easily accessing the available documentation. Let's run the app. So if we select the one entry in the pop-up menu, then the list box is populated with the values for such multiplication table, and the same every time we select any of the available entries in the pop-up menu. As you can now see, the use of loop constructions greatly simplifies the execution of repetitive code, so it results in a more cleaner and concise code instead of having to repeat a total of n times the same lines of code in order to achieve the expected behavior in the app. I hope you found this lesson interesting because you learned how to use the loop constructions in your own apps. In the next lesson, we're going to put into practice everything we've seen until now in order to create an app where we're going to be using the pop-up menu, the list box, also the text field control, the conditional expressions, variables, and of course, the loop structures. Please like and subscribe our YouTube channel so you'll be notified more videos are available. Thanks for watching.